I am Anil Kumar. Welcome to my YouTube channel. Let me thank all the viewers and subscribers for watching my videos and posting brilliant questions. These are tough times. Most students are trying to learn from home. We are providing free services from our YouTube channel. You keep posting your questions and we'll be answering them. I'm also conducting Zoom classes. You can always attend and learn. Register for our Zoom classes. Now, here is a brilliant question from one of our subscribers who wants to understand about optimization. So, this is calculus. I put it under exam review since these questions are seen in examinations. So, the question here is a cylindrical biscuit tin has a close fitted lid which overlaps the tin by 1 centimeter as shown. So the print is very small here. So that is the tin cover which fits over the tin, right? Okay. The radii of the tin and the lid are both x centimeters. So we are given that this radius here is x centimeters. That is radius. And this is also x centimeters. Okay. Now, the tin and the lid are made from a thin sheet of metal of area 80 pi centimeters square, right? So area we are given as 80 pi centimeters squares. Okay. And there is no wastage. The volume of the tin is V centimeter cube. Show that the volume is, so I've written this formula right here for the convenience. We are given area of the tin as 80 pi centimeter square, and we need to show that volume is pi times 40 pi minus 40x minus x square minus x cube. Find the maximum volume if x can vary. So this width can vary. Find the percentage of the sheet used in the lid for maximum volume. That is what basically you have to find. You have to find these two things. So once again, we are given a tin. This is cylindrical in shape. The radius is x. The lid also has a radius of x, which just fits in. Now, the lid overlaps by 1 centimeter as shown here. So that is the overlap when it fits on the container itself. We are given that the area of the tin utilized for making the cover, the lid, and the container is 80 pi centimeters square. We need to find the value of x, which will give us the maximum volume. That is the question. That is one part. We're already given that the area is 80 pi. We're not given the length. So this area which is given to us of the material can help us find a relation between x, the radius, and the height or length of this particular tin, right? So first part is that we have to show that v equals to pi times 40x minus x square minus x cube. So that means that this question probably comes from GCSE because they give you hints to solve a question, right? So most probably it is GCSE, right? So level A or A plus, right? So there is, I think, from that side. And we need to show that the volume is this. Find maximum volume if x can vary. So we have to find the value of this. Find percentage of sheet used in the lid for maximum volume. So once we figure out what this value of x is, we'll find what is the area of this particular lid, and then we can calculate the percentage. So I hope the question is absolutely clear. Now let us see how to solve this type of question. So here I have enlarged a bit. So again, we are given that the area of the tin is 80 pi centimeter square. We need to show that the volume is pi times 40x minus x square minus x cube. The maximum volume of the container if x can vary. So only thing which can vary is x, all other things are fixed. Find percentage of sheet used in the lid for maximum volume. So that is kind of very important question, two things. Okay. Well, definitely when the x changes, the length or height will also change since the material cost is fixed, right? Okay, but we'll focus on x which is going to vary. Okay. Now to begin with, we are given that the area is 80 pi. Now what is the total area of the material? If you see that top surface, it is circular, that means pi r square. Now biscuit tin will be covered from the bottom also, so we also have pi r square as the circular area of this particular portion. So that means two circles, and that gives us 2 pi r square, right? So that covers the area of the bottom and area of the top. Then we have area of 2 pi x. Now this is one unit, right? So let me write down clearly that we are given that this dimension here is 1 centimeter. So 2 pi r is x, so times 1 will give us 2 pi x as the area of this curved surface which overlaps, right? This area is 2 pi x. And 2 pi xh is the area of the curved surface right there. Is that clear to you? So that comprises the total area of the material. And when we equate this, pi and pi cancel, right? So we can cancel with all 2's will cancel, correct? So we'll get this as 40 and the pi's will cancel. So it simplifies. So we get what is written here, 40 equals to x squared plus xh. Now from here we can isolate h. That is kind of important, right? That is the purpose. So now we know what h is. So taking these x squared and x to the left side, we get 40 minus x squared minus x, and the coefficient of x is now divided into that, so we get the value of h. Now we know that the volume is pi r square h, right? So we can now substitute this particular value of h right there. So we get the expression for volume as pi x squared 40 minus x squared minus x over x. Now you can simplify this cancelling these x's, right? So we get pi x 40 minus x squared minus x, which can be rearranged taking x inside, right? And then you get the required expression, which is right there. So I hope this part is absolutely clear. So the volume of this tin is pi times 40x minus x squared minus x cubed, right? Now we need to maximize. So maximize means we'll find the critical number, right? So let's find the critical number now. So that is to say that we'll find the derivative with respect to x equated to 0, right? So that is what we are going to do now. So the derivative of this expression, which is a polynomial, power rule will be applied. And so we get the derivative as shown here. Pi times 40, 2x and 3x squared. Now to find critical number, we are going to equate this to 0. So that means pi cannot be 0, so inside term should be 0. Rearranging this with positive coefficients, 3x squared I'm writing first, right? So reverse this order. Plus 2x minus 40, as if taken this side on the right side, equals to 0. Now you can apply the quadratic formula to find the value of x, right? So the value of x is minus 2 plus minus b squared. So 2 squared is 4 minus 4ac. 4 times 3 times 40. Minus minus makes it positive. so we get positive 480, divided by twice A, which is 2 times 3, so we get 6, correct? So we use the quadratic formula here, which you know is uh, minus B plus minus square root of B square minus 4AC, correct? Over 2A, right? So we utilize this particular formula, and that comes out to a very nice value, 10 over 3, right? So the x value is 10 over 3. That is the critical number. Now you can actually analyze this, whether it will be a maximum or minimum, by finding the second derivative. So here is your first derivative. It's a polynomial. Power rule can be applied. So derivative of minus 2x is minus 2, right? And for minus 3x squared is minus 6x. So the derivative is negative, less than 0, concave down means maximum for critical number, right? So it's a very easy proof that this critical number actually represents a maximum. So let's calculate the volume now, substituting x as 10 by 3 in the expression for volume, which is given right there. So we are substituting this value of 10 by 3 here for x, right? So once you do that, 10 by 3 and then x squared means 10 by 3 squared, cube is 10 by 3 cube. And once you expand and simplify as shown here, 40 times 10 is 400 over 3, 10 squared is 100, 3 squared is 9, cube 1000 over 27. Take 27 as the common denominator, so this gets multiplied by 9, that gets multiplied by 3, this is by 1, and when you add this up, you get 2300 pi over 27 as your volume. Perfect. So we have the volume, and we also shown that it is indeed a maximum since the second derivative is negative, right? So we've done this part of finding the maximum volume. Now let's see how to find the percentage of the sheet used for the lid. Well, we know the value of x, so from there we can figure it out. So here is the percentage calculations. Now we'll calculate the percentage of the sheet used in the lid for maximum volume. The total area is given to us as 80 pi, right? That is the total area. We know now x is 10 over 3 for maximum volume, correct? So we can substitute this value to find the area of the lid, right? So which means a circular surface and this number, this which fits. So it is pi x squared for the circle, 2 pi x for the thing, 1 centimeter, which covers the container. So when you substitute 10 over 3, you can calculate the value of the lid area comes out to be 160 by 9 pi. Okay? So it's an easy calculation which is shown here. Now we need to find the percentage area, which really means the area of the lid over total area times 100. Area of the lid is pi 160 over 9 over 80 pi. Pi and pi cancel, multiply by 100. 160 divided by 80 is 2 times, right? So we get 2 times 100 as 200 divided by 9. And so it's 22.2%. So that is the percentage of lid material to total for maximum volume, and is 22.2%. Perfect. So I hope it is absolutely clear. So it's a very brilliant question, and I hope the solution which we have gone through helps you to understand the concepts. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that will be great. Thanks for your time and all the best.